This lecture is going to cover properties of water. So let's go back to this slide that we've been looking at with shows basically these properties of water where water is partially negative on the oxygen and partially positive on the hydrogen. So we talked about covalent bonds in the last lecture. Let's talk hydrogen bonds because hydrogen bonds really are critical to understanding properties of water. So what happens when water molecules get together is they form something called a hydrogen bond that's usually represented by a dotted or a dashed line. And that's to show that this is a really weak bond. And that bond actually forms between molecules. So take note, there's a molecule, there's a molecule. That's different than what we were talking about with covalent bonds where you had something like a hydrogen to hydrogen bond. That's bonding between atoms. And of course there's bonding between atoms within the water molecule. So this is a polar covalently bonded molecule. And here's another polar covalently bonded molecule. And they are weakly attracted to one another through the hydrogen bond. So what you see is minuses and pluses lining up with one another. And these are very, very weak. They break at room temperature. Water sitting in a glass will break and form every few trillionth of a second. It is that fast. So the hydrogen bond is very dynamic. It's constantly breaking and forming. But it's really, really important to all the properties of water that we want to discuss. So the first property of water that I'd like to talk to you about is transpiration. And I guess transpiration is the process. The property in and of itself is cohesion and adhesion. So with transpiration, that only occurs because water molecules are sticky. They stick to one another, which means they're cohesive, and they stick to other things, which means they're adhesive. So let's go back to this. And so what that means is that collectively, the water molecules, they like to stick to one another. And we just say stick to one another because they bond through the hydrogen bond. And that bond is constantly breaking and forming. And so the collective hydrogen bond makes water molecules stick to one another. Now that's really, really important when you consider something like photosynthesis. Photosynthetic organisms are the base of the photoautotrophic food system that we're going to be studying, right? So watch this. Here's a tree, and here's some rain falling. And what happens is that the leaves can't actually use that rain that's falling. It has to come down into the earth, and the roots actually take up water. And then water travels through these straw-like openings out and into the leaf. And this is actually a passive process, which you have to think is pretty miraculous since water molecules are moving against gravity. So all plants do this. Water is actually moving against gravity. So how does that work? How that works is that water molecules stick to one another. So inside of this straw, just like if you were sucking up water in a straw yourself, water stays in a continuous column within these openings. And then at the top of the leaf, how water travels up is because water will actually be diffusing through the leaf. And we'll talk about the anatomy of the leaf a little later in the course, but let's just suffice to say that there are openings on the underside of a leaf where water is able to escape. And when that happens, this is called evaporation. When that happens, it pulls the water up. It's basically the action of sucking on the straw that creates that negative vacuum that causes water to be pulled up the straw. So transpiration is a critically important process in terms of life on Earth, and that happens because of the properties of cohesion. So that's this is one property, cohesion adhesion, and this is your second property, and that is evaporative cooling or evaporation. Adhesion also plays into this, and that is because water will stick to the straw. So as it moves up here, it'll stay pretty steady. It'll drop a little bit, and then it'll come back up. So it kind of sticks its elbows out into the straw and holds on in that way. So transpiration involves cohesion and adhesion as well as evaporation. So those are two properties of water. There are more. The third property of water is specific heat. And with specific heat, when you have large bodies of water, okay, these large bodies of water essentially go ahead and they trap heat. So solar radiation that occurs during the day is absorbed basically in the bonds. So we have water molecules, and those are breaking and forming constantly. And what happens is that heat from the sun is absorbed in that bond, okay, and it breaks, and then it forms, and then it breaks, and then it forms. Well, collectively, those bonds breaking help absorb heat, and this is how water stores solar radiation or heat. So big bodies of water will store massive quantities of heat. We say that water has a really, really high specific heat because it has a high capacity for storing energy by way of heat. And so this actually helps regulate our climate on Earth. When you have a place like Bellingham where we have a large body of water, the Puget Sound, it moderates our climate because the heat from the day gets absorbed, and then at night it releases heat. And so our daytime highs aren't quite as high as they would be without a body of water nearby, and our nighttime lows aren't quite as low. So our temperature during the days and during the nights doesn't change much, and that is because of this huge body of water that we have right next to us. And so this happens all over the world, all over our planet. Bodies of water butt up against land masses and release heat, and they accept heat. And it's a critically important process for stabilizing climate on Earth. The last would be surface tension. And you know surface tension. You've seen images like this, or you've gone to bodies of water and you've seen insects actually standing on water. You probably did little water experiments when you were in grade school. You know that the surface of water, there is actually a tension on that, and you can see that here. And so let's go back to, we'll write on here. Okay, so if this is the surface of the water, what you have are water molecules that are in the mix, and you have water molecules that are up here, way up at the top. And the ones that are at the air-water interface, okay, so draw some water molecules, some hydrogen bonds. The ones at the air-water interface, which would be up here, they get pulled in all these directions, right, by hydrogen bonds, but they don't get pulled up, right? That doesn't happen because there aren't water molecules, liquid water molecules above it. So what happens is you have water molecules at the surface only getting pulled out and down, and that creates a tension on the surface. So that provides environments for organisms to live, but what it also does is it inhibits evaporation. And what that does is it links right in with what we were talking about with specific heat. It means that these bodies of water, evaporation is inhibited. It doesn't mean that evaporation doesn't happen. It just means that it's going to take more energy for water molecules to escape into gas. Big picture is that bodies of water will hold more heat than escapes. And one of those reasons is because of surface tension. Okay, that concludes your lecture on water.